Problem number 2. Express secant theta minus sin theta tan theta as a single function of theta. So, sin theta minus sin theta tangent theta. So, convert secant theta into 1 over cosine theta and convert tangent theta into sin theta over cosine theta. So, then, multiply sin theta to sin theta over cosine theta. So, our equation will be 1 over cosine theta minus sin theta squared over cosine theta. Then, subtract. So, our equation will be 1 minus sin theta squared over cosine theta. Then, convert 1 minus sin theta into cosine squared theta. So, our equation will be cosine squared theta over cosine theta. Then, divide. So, cosine squared theta divide cosine theta is equal to cosine theta. So, our answer is cosine theta. Then, number 3, express tan squared x minus secant squared x in terms of sin x and cosine x and simplify. So, tan squared x minus secant squared x. So, convert tan squared x into sin squared x over cosine squared x. Then, convert secant squared x into 1 over cosine squared x. Then, so, subtract. So, sin squared x over cosine squared x minus 1 over cosine squared x. So, if we subtract this, our answer is sin squared x minus 1 over cosine squared x. Then, factor the negative sign. So, our equation will be 1 times 2 or 1 negative sign quantity times 2 quantity 1 minus sin squared x over cosine squared x. Then, convert 1 minus sin squared x into cosine squared x. So, our equation will be negative times cosine squared x over cosine squared x. Then, divide. So, negative cosine squared x over cosine squared x is equals to negative 1. Number 4. So, number 5. Express a cosine 270 degrees minus theta and b tangent pi plus x as a function of theta or x alone. So, first, let's solve the problem number A, which is cosine of 270 degrees minus theta. So, to solve, so use the sum and difference identities. So, formula for sum and difference identities is cosine x minus y is equals to cosine x times cosine y plus sin x sin y. So, substitute. Let 270 degrees be our x, then theta our y. So, substitute. Our equation will be cosine of 270 degrees times cosine theta plus sin 270 sin theta. So, cosine 270 degrees is equals to 0. Then, sin 270 is equals to negative 1. So, 0 times 2 cosine theta plus negative 1 times sin theta. So, cosine theta times 0 is equals to 0. Then, negative 1 times sin theta is equals to negative sin theta. So, B. Problem number B. So, tangent of pi plus x. To solve, use sum and difference identities, which is tangent of x plus y is equals to tangent of x plus tangent y over 1 minus tangent of x and tangent of y. So, our equation will be let x be the pi and y be our x. So, substitute the value. So, our equation will be tangent pi plus tangent x over 1 minus tangent pi tangent x. So, tangent pi is equals to 0. So, solve 0 plus tangent x over 1 minus 0 times tangent x. So, our answer will be tangent over 1. So, our answer is tangent x. Problem number 6. So, use a half-angle identity to find the exact value of sine negative 22.5 degrees. So, sine of negative 22.5 degrees is equals to sine of negative 45 over 2. So, the formula for half-angle identity is sine theta over 2 is equals to plus minus the square root of 1 minus cosine theta over 2. So substitute the value. Our equation will be plus minus the square root of 1 minus cosine 45 over 2. So cosine 45 is equals to 1 over the square root of 2. So substitute. Our equation will be plus minus the square root of 1 minus 1 over the square root of 2 over 2. So multiply 1 square root of 2 to square root of 2. Our equation will be 1 minus plus minus the square root of 1 minus 1 over the square root of 2 times 2 times the square root of 2 over the square root of 2 over 2. So bring 2 to the denominator. So plus minus the square root of 1 is minus the square root of 2 over 2 over 2. So bring down 2. So our denominator will be 2 times 2. So multiply. So 2 times 2 is equals to 4. So our equation will be plus minus the square root of 1 minus the square root of 2 over 4. So then factor out the or get the square root of 1/4. So the square root of 1/4 is 1/2. So our equation will be plus minus 1/2 of square root of 2 minus square root of 2. Then number 9, verify that each equation is identity. So 9, secant squared b is equals to 1 over 1 minus sine squared b. So first, to convert 1 minus sine squared b, so use Pythagorean identities to convert. So 1 minus sine squared b is equals to cosine squared b. Then convert liwat. So 1 over cosine squared b, convert. So use reciprocal identities. So 1 over cosine squared b is equals to secant squared b. So our answer is secant squared b. So number 10, cosine 2a is equals to cotangent a minus tangent a over cosecant a secant a. So first, to solve or to prove our identities, convert cotangent a into cosine a over sine a. Then tangent a into sine a over cosine a. Then cosecant a is equals to 1 over sine a. Then secant a is equals to 1 over cosine a. So our equation will be cosine a over sine a minus sine a over cosine a is equals to 1 over sine a times 1 over cosine a. So then, solve cosine a over sine a minus sine a over cosine a is equals to cosine squared a minus sine squared a over cosine a sine a. So then, multiply sine a. So our equation will be cosine squared a minus sine squared a over cosine a sine a over 1 over sine a cosine a. So then multiply sine a cosine a to cosine squared a minus sine squared a over cosine a sine a. So bring upwards. So our equation will be cosine squared a minus sine squared a over cosine a sine a. So times sine a cosine a. So cancel the denominator. So the remainder will be, or the remaining will be cosine squared a minus sine squared a. So convert, use double angle identities. So convert cosine squared a minus sine squared a into cosine 2a. So our identities will be cosine 2a. So number 11, tangent. So tan squared x minus sine squared x is also tan x sine x squared. So convert tangent squared x into sine squared x over cosine squared x. So our equation would be sine squared x over cosine squared x minus sine squared x. Then multiply since sine squared x by cosine squared x over cosine squared x. So our equation will be sine squared x over cosine squared x minus sine squared x cosine squared x over cosine squared x. Then solve. So minus, since they have same denominator, so our equation will be sine squared x minus sine squared x times cosine squared x over cosine squared x. Then factor out sine squared x from the numerator. So our equation will be sine squared x times 2, 1 minus cosine squared x over cosine squared x. Then convert, use Pythagorean identity. So 1 minus cosine squared x is equals to sine squared x. Then factor the sine squared x from the equation. So our equation will be sine squared x times 2 sine squared x over cosine squared x. Then convert. So convert sine squared x over cosine squared x into tangent squared x. So our equation will be sine squared x times 2 tangent squared x, or tan x sine x squared. So solve its equation. Give solution in exact form. So problem number 1. So it is read as 3 times the natural log of x is equal to 13. So get the value of x. So to get the value of x, first divide both sides by 3 to get 3 from the left side. So 3 natural log of x over 3 is equals to 13 over 3. Then since natural log as a base of e, so our equation will be natural log base e of x is equals to 13 over 3. We can now convert to its exponential form. So e raised to 13 over 3 is equals to x. So then convert e into numerical form. So e is approximately 2.7182. Our equation will be x is equals to the cube root of 2.7182 raised to 13, or our x is equals to approximately 76.1976. Problem number 2. It is read as log of 2x plus 7 is equals to 0.25. So since we don't have a base, if there is no base, assume the to be base is 10. To be base 10. So log base 10 of 2x plus 5 plus 7 is equals to 0.25. We can now convert to its exponential form. So convert 10 raised to 1/4 is equals to 2x plus 7. Transpose 7 from the right side of the to the left side, or subtract 7 from both sides. So 10 raised to 1/4 minus 7 is equals to 2x. Then subtract both sides by 2. So our x is equals to 10 raised to 1/4 minus 7 over 2, or x is approximately negative 2.6109. Number 3, log base 2 of x cubed plus 5 is equals to 5. So convert log base 2 of x cubed plus 5 is equals to 5. So its exponential form is 2 raised to 5 is equal to x cubed plus 5. Then simplify 2 raised to 5. So 2 raised to 5 is equals to 32. Then subtract 5 both sides. So 32 minus 5 is equals to x cubed. So 32 minus 5 is equals to 27. Then get the cube root of x and 27. So the cube root of x cube is equals to x. Then the cube root of 27 is equals to 3. So our x is 3. So number 4, log base 4 of quantity 3x plus 1 times the quantity of x minus 4 is equal to 2. Convert to its exponential form. So our equation will be 4 squared is equals to 3x plus 1 times 2x minus 4. So simplify 4 squared. So 4 squared is equals to 16. Then expand. So 3x plus 1 times 2x minus 4 is equals to 3x squared minus 12x plus x minus 4. So combine like terms. So 12x, negative 12x plus x is equals to 11x. Then subtract 16 both sides. So cancel 16. Then our equation will be 3x squared minus 11x minus 4 minus 16 is equal to 0. Then minus 4. So negative 4 minus 16 is equals to negative 20. Then factor to get the value of x. So the factor of 3x squared minus 11x minus 20 is x minus 5 and 3x plus 4. So get the value of x. So the value of x are x is equals to 5 and x minus is equals to negative 4/3. Since the logarithm cannot be negative, then since the logarithm cannot be negative in its equation, so then the correct answer is x is equals to negative 5. So problem number 5, log base x plus log of 13 minus 3x is equals to 1. So log of x is equals to 0. Then log of 13 minus 3x has no base. So if there is no base, assume to be base 10. So our equation will be 0 plus log base 10 of 13 minus 3x is equals to 1. So convert to its exponential form. Our equation will be 10 is equal to 13 minus 3x. So 10 raised to 1 is equals to 10. So since any number raised to 1 is equal to itself. So then subtract 13 both sides. So our equation will be 10 minus 13 is equals to negative 3x. So divide both sides by negative 3 to get the value of x. So our x is equal to 1. Number 6, natural log of 6x minus the natural log of x plus permutation is equal to natural log of 4. I don't know kung paano basahin. So change permutation into 1. So permutation is equal to 1. So our equation will be natural log of 6x minus natural log of x plus 1 is equal to natural log of 4. So to solve the value of x, first use quotient rule law of logarithm to transform the equation. So our equation will be natural log of 6x over x plus 1 is equals to the natural log of 4. So then multiply first cancel out the ln or the natural log, so or drop. So the remaining will be 6x over x plus 1 is equal to 4. So then multiply both sides by x plus 1. So 6x over x plus 1 times 2x plus 1 over is equal to 4 times x plus 1. So cancel x plus 1 from the denominator. So then substitute 4 times x plus 1 is equals to 4x plus 4. So our equation will be 6x is equal to 4x plus 4. Then subtract both sides by 4x. So our equation will be 6x minus 4x is equal to 4. So 6x minus 4x is equal to 2x. Then divide both sides by 2. So the value of x is equal to 2. So number 7, natural log of 5x is equal to 16. So always remember the natural log as a base of e. So our equation will be natural log base e of 5x is equal to 16. Convert to exponential form. So e raised to 16 is equals to 5x. Then divide both sides by 5. So x is equals to e raised to 16 over 5. So convert e to numerical form. So e is equals to approximately 2.7182. So x is equal to 2.7182 raised to 16 over 5. So x is approximately 8,886,115.496 or pwede ring maging answer na to. So x is equal to 2.7182 raised to 16 over 5 because the answer is 2b. So number 8, the natural log of x plus natural log of x cubed is equal to 12. So first put down the exponent 3 of x cubed in front of the natural log of x cubed. So our equation will be, if you put down this exponent, our equation will be the natural log of x plus 3 times natural log of x is equal to 12. So combine like terms. So natural log of x plus 3 times natural log of x is equal to 4. The natural 4 times the natural log of x is equal to 12. So to get the value of x, so or to convert to exponential form, divide both sides by 4. So to cancel out the 4, so 4 natural log of x over 4 is equal to 12 over 4. So 12 over 4 is equal to 3. So ln of x is equal to 3. Then convert. So remember that natural log as a base e always. So ln e, or natural log base e of x is equal to 3. So its exponential form is e raised to 3 is equal to x. So e is equal to 2.7183. So x is approximately 20.0859. So number 9, log base 3 of quantity x squared minus 9 is equal to 3. Convert to exponential form. So 3 raised to 3 is equal to x cubed minus 9. So simplify 3 raised to 3. So 3 raised to 3 is equal to 9. Then add 9 both sides. So 9 plus 9 is equal to x cubed. Or 9 plus 9 is equal to x squared. Then add, so 9 plus 9 is equal to 18. So get the square root of x and 18. So the square root of x cubed, or x squared rather. So the square root of x squared is equal to x. Then the square root of 18 is equal to 3 times the square root of 2, or x is approximately 4.2426. So problem number 10. Natural log raised to the natural log of x minus the natural log of x minus 4 is equal to the natural log of 3. So to solve, first put down the exponent, which is natural log of x, in front of the natural log of a raised to natural log of x. So put down this exponent into the front. So our equation will be natural log of x times to the natural log of b minus natural log of x minus 4 is equal to natural log of 3. So since natural log of a is equal to 1, so multiply it to the natural log of x. So natural log of x times 1 is equal to the natural log of x. So use quotient rule law of logarithms to transform the equation. So we will use the quotient rule law since it has it is minus. So our equation will be natural log of x over x minus 4 is equal to natural log of 3. So drop or cancel ln or drop the ln. So our equation will be x, or the remaining x is equal x over x minus 4 is equal to 3. Multiply both sides by x minus 4. So x over x minus 4, so times x minus 4, so cancel x minus 4 from the denominator. Then 3 times x minus 4 is equal to 3x minus 12. So x, then subtract both sides by 3x. So x minus 3x is equal to negative 12. So x minus 3x is equal to negative 2x. Then divide both sides by 2. So or divide both sides by negative 2. So our x is equal to 6. Number 11. So log base 7 of quantity 3x plus 2 minus the log base 7 of quantity x minus 2 is equal to 1. Since they have the same base, we can use quotient rule law of logarithm. So log base 7 of 3x plus 2 over x minus 2 is equal to 1. We can now convert to its exponential form. So 7 raised to 1 is equal to 3x plus 2 over x minus 2. So multiply both sides by x minus 2. So 7x times x minus 2 is equal to 7x minus 4. And 3x plus 2 over x minus 2 times 2x minus 2. So cancel out. x minus 2 from the denominator. So the remaining are 7x minus 14 is equal to 3x plus 2. Subtract 3x both sides and 14 both sides, and add 14 both sides. So our equation will be 7x minus 3x, because we subtracted 3x both sides, then 2 plus 14. So 7x minus 3x is equals to 4x, then 2 plus 14 is equals to 16. So divide both sides by 4. The value of x is equal to 4. So number 12, last number. So log base 16 of the square root of x plus 1 is equal to 1/4. Convert so to its exponential form. So 16 raised to 1/4 is equal to the square root of x plus 1. So raise both sides by 2 to cancel the square root of x plus 1. So 16 raised to 1/4 raised to 2 is equal to 16 raised to 1/2. Then cancel the square root of x plus 1, so the remaining are x plus 1. So simplify 16 raised to 1/2, or 16, or the square root of 16. So the square root of 16 is equal to 4. So 4 is equal to x plus 1. Then subtract both sides by 1. So 4 minus 1 is equal to x. Then the value of x is 3.